In this video, we will be talking about intersection and union. This will help you with the problem 5.25 from our assignment. Intersection. When we use our symbology, we say the probability of A, and then this symbol here, which we call intersection, B. The probability of A intersect B is equal to the probability of A times the probability of B, if and only if, this symbol means if and only if, A and B are independent. A and B are independent. All right. This symbol, you might notice it sort of looks like an A a little bit. In English, we'll just think of it as and. Okay. Intersection is and. We say A and B. The probability of A and B will simply be the individual probabilities multiplied by each other, given if they are independent, if indeed they're independent. Next, union. Union is or. Intersection is and, union is or. And we use this symbol. Probability of A, U for union. A or B, we say. The probability of A or B is equal to the probability of A plus the probability of B minus the intersection probability of A and B. Okay, so we'll add A and B together and we'll subtract over any double counts essentially. Let's look at an example of this. Example. Okay, let's say that we have some college student, Jenny. All right, Jenny finished a 2-year school, maybe like Jacksonville College. Jenny just finished a 2-year school. She's excited, all right. She wants to go off now to a university. And let's say that the two universities that Jenny's interested in are University of Texas and Harvard. She's been a great student. Let's let T be the event that she gains admitted to. Admitted to University of Texas. Okay. And let's let H be the event admitted to Harvard. Not that she's attending the school, but that she has gained admission. Okay. And let's say her chances of getting into Texas, her probability of being admitted into Texas is 50% or 0.5. And let's say the probability of her being admitted into Harvard is 0.4. All right, and let's say the chance that she gets admitted into both, the intersection we say the probability of Texas intersect Harvard, we read this as again, and Texas and Harvard is 0.3. Okay, the first thing I want to note is these events are not independent, because if we multiply 0.5 times 0.4, we get 0.2. Okay, and that's not this 0.3 here. And we'll talk more about independence later on, but it makes sense because we think of independence as when we have information about one, it doesn't give us information about another. If I know I've been admitted into Texas, it probably gives me some idea if I'll be admitted into Harvard and vice versa. So, in order to investigate this situation, what we're going to do is use a Venn diagram. All right. And a Venn diagram is something that you have seen very often in math, starting back when you were probably pretty small. You're simply going to draw two, in this case, two intersecting circles. All right. One is going to be your Texas circle, and one is going to be your Harvard circle. And then I'm going to draw a rectangle that contains all of these. Okay. And we typically call this rectangle the universal set. All right. This is everything. Everything that can happen will be in here. Well, I'm going to place these probabilities in, but the key is put the intersection first. Okay. This is key. Intersection first. All right, so the probability that Jenny gets admitted to Texas and Harvard is 0.3. Well, that's this part in here. This overlap, this intersection, is both Texas and Harvard, so I'm going to place a 0.3 in here. There's the 30% that Jenny is admitted in both. Well, what is her chance of being admitted in Texas? Well, it's 0.5, so that's this circle. But we've already got 0.3, so how much is left? That's right, 0.2. Notice 0.2 and 0.3 together is 0.5. This 0.3 is the times that Jenny will be Texas and Harvard. This 0.2 is just Texas. Okay, so now what over here is just Harvard? Well, Harvard total is 0.4. We've already got 0.3, so the remainder is 0.1. 10% of the time she will gain admittance to Harvard, but not to Texas. All right. Well, the question is, what is out here? Well, what's out here is did not gain admittance to Texas or Harvard. Maybe she's going to go somewhere else. All right, but out here is just the percent that is not Texas or Harvard. Well, it's the rest. 0.2 and 0.3 is 0.5 and 0.1 is 0.6. So the rest out here is 0.4. That is 40% of the time Jenny will not get into Texas or Harvard. Okay, using this picture, we can answer many questions. Let's consider question A here. What is the probability Jenny gets admitted to either school, okay, to either Texas or Harvard? Well, it would be all of these numbers summed up. It would be 0.2 plus 0.3 is 0.5 plus 0.1 is 0.6. All right, so this probability here would be 0.6 or 60%. She has a 60% chance of getting admitted to either. Okay. B. What is the probability Jenny gets into neither school? Well, that'd be this, wouldn't it? This is neither school, 0.4. Or 40% I could write, but 0.4 is good enough there. All right. C part. What is the probability Jenny gets into exactly one? Exactly one. Well, this is her getting in to either of them. But this is an overlap. This is both. Exactly one would be Texas, 0.2, or Harvard, 0.1, but not this 0.3. So the chance that she gets into exactly one would be 0.2 plus 0.1. Well, that's 0.3. Okay, she has a 30% chance of getting into one or the other, but not both. All right. Using this information and this Venn diagram, you should be able to answer now problem 5.25. You're simply going to draw this same Venn diagram. It's dealing with stoplights, all right, you'll have two intersecting circles. The key is this right here. All right. Find the intersection first. Find that overlap and then find those other two. All right, you should be able to answer those questions at this time.